Welcome back. In this video, I'll cover considerations for managing data. As you're managing data, you'll have lots of different considerations that you'll want to account for. I'll cover some of the most important and basic of these considerations in this video. Before you do anything else, take inventory of your data. Even before you begin collecting data, ask yourself what type of data you plan to collect. Data type could be video data, spreadsheet data, simulation data, images, or something else. The answers to this question will factor into how your data is going to be stored, saved, and shared. Think about what file formats and types you'll be using. You don't need to know everything right away, but think about it as you begin to plan. Also think about the programs that you're planning to use in creating these various file formats. Based on how much data you're planning on collecting, how do you plan to store all of it? And while you're thinking about that, a good rule of thumb is the 3-2-1 rule of data storage. It's best practice to keep 3 copies of your data, 1 primary and 2 backups, in at least 2 types of storage media, such as local drives, network attached storage, or in the cloud, and then keep at least 1 copy offsite, maybe in secure storage or in the cloud. Keeping an offsite copy enables geo-redundancy. No one wants to think about it, but something like a fire, earthquake, or flood could happen and destroy the servers where you're storing your data. You don't want to lose all of that information with no recourse. It is not enough just to have multiple copies in the same place. As you're naming files, some rules of thumb are to limit the length to 32 characters maximum. This ensures interoperability between systems. Some systems may be able to store more, but virtually all can handle at least 32 characters. It is best to avoid spaces, hyphens, dashes, or periods except before the file extension. Don't use special characters. Characters like ampersands, the %, hashtags, exclamation points, or other special characters should not be used in the file names. The main exception is the underscore, which can be used instead of a space. You may also use what's known as camel case, using different cases of letters to indicate different words within a file name. Once again, the purpose of this is to avoid situations where you're running into potential compatibility issues with files running in programs. Sometimes programs require these symbols that you might use within normal naming conventions without thinking too much about it, but then that creates interoperability issues. Keeping it simple with underscores and camel case prevents a lot of these issues. Whatever you do, be consistent. It's especially true with things like dates and numbers. A good basic format for date is year, month, day. That promotes a good order for lists as they display in your file explorer. If you did month first, then day, then year, it would order by month first, and that could get confusing depending on the length of your project. If you need to use numbers to denote specific iterations or experiments, use leading zeros. For example, for a sequence of 1 to 10, you would use 0, 1 through 1, 0. For a sequence of 1 to 100, you would use 0, 0, 1 to 0, 1, 0 representing 10 to 1, 0, 0 for 100. Once again, this just makes your life easier as you're ordering files. But it does require a little understanding of how many files of a particular name you intend to create. As far as file formats are concerned, if possible, best practice is to use non-proprietary or open file formats and then store them unencrypted and uncompressed. That may not always be possible. I know that even within the repository at the Colorado School of Mines, we keep some files compressed just for the sake of downloading them. But if it's possible to avoid encryption and compression, that is best practice. Some examples of proprietary formats are from the Microsoft Office suite. Excel files are stored as .xls or .xlsx. There are a few alternative open formats for spreadsheet data like .csv, comma-separated values, .tsv, tab-separated values, or ASCII, the American Standard Code for Information Interchange. Additionally, Word documents are stored as .doc or .docx. The open alternative here is plain text, .txt, or if formatting is necessary, use archival PDF.pdf format. PDF is an open format despite being somewhat challenging to manipulate outside of Adobe's products. PowerPoint is similarly closed and is stored as .ppt or .pptx. The open equivalent is once again archival PDF format. Photoshop or .psd files are better stored as .tiff files. That is just a standard uncompressed image format. Finally, QuickTime or .mov files are better stored as MPEG-4 or .mp4, as you might be more familiar with. There are certainly more proprietary file types and many more open file types as well. Regardless of what your data type is, see if you can find an open format which is beneficial, as companies can dissolve or cease to support proprietary formats over time. Generally, data needs to be secured in some way, shape, or form to avoid data loss or breaches. In certain situations, like if you're dealing with human subjects, it is extremely important to keep those human subjects' identities private. In many cases, it's preferable not to collect personally identifiable information on human subjects at all, though it may be necessary for medical reasons or otherwise. If you're collecting personally identifiable information, be aware that data needs to be particularly secured. For example, protected populations who may be in vulnerable situations such as children or other at-risk groups must not have their data shared inappropriately lest they be unduly put at risk. This is also true for non-human protected populations like endangered species. You would not want to share the location of elephants that you're studying, as they could be the target of poachers. Data security is of particular concern to institutional review boards who will make determinations about your research and whether the risks are worth the knowledge gained. You do not want data security to be a risk within these reviews. Additionally, depending on what it is that you're researching, you might be working with controlled unclassified information. This is information shared with particular groups by the government that they don't want shared more broadly. If you're borrowing data from other researchers or conducting research on contract with a corporate entity, there may be data use agreements that the data is subject to. You'll need to be aware of those agreements and what you may need to do to mitigate risk of unintentional disclosure. Also, if you have proprietary data that you don't want to get out, think about how you're going to secure that. Likewise, you could have patentable data. If you intend on filing a patent, you don't want to have your data leaked and ruin your opportunity to benefit from the protections of patents. So far, I've covered some of the considerations for data management and why you should care about data management. Up next, I have prepared a quiz where you'll review what I have covered in this video, including file naming best practices and open non-proprietary file types.